So hi everyone. In this video we are going to learn a bit about circular motion. Okay. So generally I see that many students have some basic understanding about motion and NLM, friction, and whenever there is a new concept which is established like rotational motion, circular motion, they think that this is tough because from 8th, 9th, 10th standard they have known only linear things like velocity, they have known acceleration as linear motion. Now circular motion is something new to them. Like when you study something for too long, like 6, 7, 8, 9, 10, you have studied velocity, acceleration, so you're used to those terms. So even if a difficult problems comes around velocity, acceleration, this looks very simple to us. Force, because we have studied them over the years. But whenever there are uh, some variables around circular motion or rotational motion, it is the first time we are learning these chapters, right? So many students think these are outside of our domain or outside of our expertise, but that is not the case. Circular motion is very easy and it is a prerequisite for rotational motion. Now you can understand physics like it's we learn kinematics, right? Kinematics is what? Kinematics is acceleration, we learn velocity. These all are required later for NLM, matlab force, friction, these all variables are required. Similarly, in circular motion, we will learn about how an object rotates. There will be theta, there will be omega, there will be alpha, right? Using this, we will understand how torque works, how a rotation object works. When there is a rotational force, how it works. So, understand like this: kinematics is prerequisite for force, circular motion is prerequisite for rotational motion, and it is required to understand rotational motion better. Okay, try to relate stuff, it will help you grasp it better. So let's try to understand circular motion. So first things first, is circular motion only related to circular motion when an object rotates in a circle or semicircle? Is it only that? No. Even if there is a straight line and an object is moving along a straight line and there is an angle theta. Now if suppose this person is moving like this, right, with velocity v, and there is a person here, I am observing this person move from here to here, from here to here, from here to here. So here also I am, for me, the movement of this person is rotational motion, right? Because for me, I have to turn my head, right? For me, this person is moving like this, so I have to literally turn my head. So for this person, the motion of this object is rotational motion. It might not be circular, it is actually straight, but for this person, it is rotational motion. So understanding this is important. Circular motion is not always about circular motion. It can be a person traveling in straight line and other person observing it as circular motion. So now kinematics terms we know, right? This is velocity, this is acceleration, this we know. Now let's try to understand in circular motion what happens. Now suppose this is a, let's try to understand first in a circle. Now this is a circle, right? And if suppose a person is traveling like this, so angle theta is formed. So theta is our angular displacement here. It is our angular displacement. To try to relate all these terms with normal linear motion, angular displacement, this is displacement, this is velocity, there is v, there is s for displacement, right? So angular displacement is just write your linear displacement, then there is angular velocity, this is like your linear velocity, and there is angular acceleration, this is like your linear acceleration. So you can correlate the two. how does a circular motion works, how does a linear motion works, right? So angular displacement is this. So angular displacement is actually, break it down, right? If there is a circle, if a person takes entire round of the circle, what is the angular displacement? What is the angle the person will move? The angle the person will move is 2 pi, right? So if I have to take for an angle theta, how do I find theta? Theta is actually arc length by r, right? By radius. How do I validate this? If it is entire circle, the arc length will be 2 pi, this will be r will be cut 2 pi, right? So for theta, angular displacement is arc length by r. What is omega? Omega is change in angular displacement by change in time. What is alpha? Alpha is change in angular velocity by change in time. This is simple. So we have understood the terminology of angular displacement, angular velocity, angular acceleration, right? Now this is a scalar or a vector. This is a vector, right? So theta is a vector. It's an axial vector actually. So how do we find the angle? How do we understand the angle? So whatever direction the person is moving, take your fingers, curl it around. So for this person, what is the angular velocity of this? Angular velocity is inside. So inside is generally represented like this. Angular displacement, that is also inside. Same, the direction is the same for both. If a person is moving like this, right, with velocity v, what it is? I take my fingers, I curl around, outside. So angular velocity, it is outside for this person, right? So this is the terminology. This is how you understand it. Look, this was just a basic type of flow for you to understand relation between circular motion and linear motion. Just to provide a brief summary, circular motion does not mean the motion has to be circular. It can be even straight line, but a person observing it in circular motion, angular displacement, angular velocity, angular acceleration, we relate it to linear. But this is a new dimension of physics where everything we relate with angles, everything we relate with circular motion. That's it. This is just the video 1, just to get you familiar with the subject and make you feel it easier. I'll coming up with more series on this. Yeah.